In this video, we are going to talk about economic value added. It's used for capital budgeting and actually gives you exactly the same results it's equivalent to net present value. The difference is we account for the cost of capital directly in the cash flows. We take the cash flow from a project and subtract what we call a capital charge every year. The capital charge has two components. One is the interest that we have to pay investors based upon last year's invested capital. The second is effectively repayment of principal to the investors. We're going to repay principal according to the depreciation schedule, so the repayment is equal to the depreciation every year. Because net present value is independent of financing, and this is effectively taking out a loan from our investors, paying back interest plus principal at the depreciation schedule, this will actually give us the same value today as net present value. So we'll discount the cash flows in excess of the cost of borrowing, the cost of capital, discount them, and we end up with exactly the same number, net present value. So we will use the same rule. If economic value added is greater than 0 except the project, it rank orders things in exactly the same order as net present value. To show you how this is done and why it's an advantage, I'm going to do this for project B that we've been working with. The first step is just put the cash flows in. And I'm going to pull up a spreadsheet and do it on a spreadsheet as well. Here I've just set up a template spreadsheet that has the cash flows in it. The first step is figure out what the capital charge is every year. There's two components. One is repayment of principal. Now the assumption is we borrow $2,000 from the investors today and pay it back according to the depreciation schedule. If we use straight line depreciation, that means we pay back $400. That's 2,000 divided by 5 every year. I'll put that in the spreadsheet here. So it's just the amount the investors have contributed divided by 5 because there's 5 years in this project. The simplest straight line depreciation. The next thing we need to do is figure out what invested capital is. Invested capital every year is last year's invested capital minus depreciation. So if they invest $2,000 at the beginning, every year we just subtract $400 off using straight line depreciation. So at the beginning they invest $2,000. Every year we subtract $400. I'll just copy that over, and you can see we go from $2,000 to $1,600, $1,200, 8, 4, and 0. Next step is to determine what the interest charged by investors is going to be. It's last year's invested capital times the interest rate. So at $2,000 invested capital at the beginning, interest rate's 10%, gives you a $200 interest charge. So every year, it's just last year's invested capital times the interest rate. In this case, it was 10%. So as the invested capital goes down because we're implicitly repaying through depreciation, so does the interest charge. The total capital charge is the sum of the repayment of principal reflected in depreciation and the interest payment. So that's what gives us the 600 here. It's the 400 repayment of principal, depreciation, 200 interest payment, 600. The capital charge falls as the invested capital falls because of lower interest payments. The third step is to subtract the cost or the charges for capital from the cash flow to get the economic value added every year. This is the cash flow over and above the cost of borrowing. So it's cash flow minus capital charge. This will increase because the interest expenses are dropping through time. Now, the EVA, instead of investing $2,000 today, we borrow $2,000 from our investors and invest it on our behalf. So the net cash flow today in EVA calculations is 0. Finally, we take the present value of the economic values added every year. Taking the net present value actually gives us the net present value of B. So I'm going to take every one of these, divide it by 1 plus interest to the power of the number of years in the future it occurs. Do that every year and add them up. And what we get is the net present value of B, 4473. We knew that from before. But here's the difference. Every year, this tells us how much we have to generate in order to make our investors happy on an annual basis, the annual capital charge. Every year, we know the cash flows. And every year, we know how much the cash flows exceed the capital charge. This is the economic value added every individual year of the project. So the reason that we do this is because we get an annual evaluation of how the project is going, what cash flows we need to meet, and what cash flows we actually have. One final note on economic value added: often you'll be looking at an investment in a perpetuity, for example, a piece of real estate. In that case, the capital charges are equal to the invested capital times the interest rate. You don't recover any of the capital over an infinite horizon. Or if you wanted to, you could do it, but they just would get you the same answer. So the usual way you do a capital charge for perpetuity is just the interest every year on the original investment and no depreciation or repayment of capital. That's economic value added.